Section 6.2 is about rationalizing a denominator. So hopefully we know what denominator means. So denominator, of course, is the bottom of a fraction. And rationalize means no square roots. So no radicals. And that would actually include cube roots, fourth roots, but most of the problems we're going to see are square roots. Those are the only examples I'm going to worry about. But that's the rule. No radicals in the bottom of your fractions. And that's what rationalizing the denominator means. Now, sometimes it turns out that there's just different ways to write a number. And for it to be simplified, we don't want the square root in the bottom of the fraction. So let's actually make some rules for simplification. So rules for simplification. All right, like what are the steps? What should we do? Maybe I even call these steps. I like steps rather than rules. Rules seems restrictive. So first step we should always take when we're simplifying a problem is to simplify our square roots, right? So simplify square roots. In other words, we're looking for perfect square factors. And that's what we did in the previous video quite a bit. Like we'd look to see if 4 or 9 or 20, or I don't want to skip 16, it's so important. 16, 25, if any of these perfect squares are factors, then the square root can simplify. We should always check for that first. Next, we want to combine like terms. And that's really for any problem. But with square roots, we specifically look for like radicals, square roots that match. So when you're adding or subtracting, you have to have terms that match. Next, we want to always do this new step that we're going to learn called rationalizing the denominator. Which again means no square roots in the bottom of the fraction. Now, of course, if your problem doesn't have fractions in it, you don't need to do that step. But we're going to see that when you do have a fraction, that's next. And finally, again, for fraction problems, at the end, make sure your fractions are reduced. So those are the steps we're going to use here. And really, these steps will take you through all of Chapter 6 and really most of Math 65 anyways. So let's see what this rationalize the denominator step looks like. So here's an example. It's 2 divided by square root of 3. Now this looks fine, right? It's not like the 2 and the 3 will cancel. And we really can't cancel square roots with non-square roots anyways. But square roots don't belong in the bottom of the fraction. So what we do is we take whatever square root's in the denominator and multiply by the same square root in the top and the bottom. So what we're really doing here is multiplying by 1. So it's a version of 1 that when we multiply by it, in the bottom you get square root of 3 times square root of 3, which just goes right to 3. Multiplying a square root by itself always gets rid of the square root. So really what we ended up doing is moving the square root of 3 from the bottom of the fraction to the top. That's what rationalizing the denominator means. So let's try some from scratch here. Rationalize the denominator for each of the following expressions. So we're starting with a square root in the bottom. And we need to multiply the top and the bottom by that square root to get it out of the bottom of the fraction. So the top now is just 5 square root of 6. We can't combine non-square roots with square roots, so it's just put them together. They're multiplied. But in the bottom, square root of 6 times square root of 6 is just 6. Multiplying a square root by itself undoes the square root. And so this is considered simplified. Even though 5 over square root of 6 didn't look so scary, this is now the more simplified version because it doesn't have a square root in the bottom. All right, so with the two examples we've done, with this first one and this one, you can sort of see they followed that same pattern. Now, sometimes doing this rationalizing the denominator will actually end up simplifying the problem significantly, and that's when it's really a useful tool. So let's see this next one, which I sort of am figuring is gonna work out this way. So it's 20 divided by square root of 5. I multiply by whatever that square root is in the denominator on top and bottom. So I get 20 square root of 5 in the top, and on the bottom, square root of 5 times square root of 5 is just 5. There's no more square root because we squared it. Now this is where, after you rationalize the denominator, we should look to see if we can reduce our fraction. 20 divided by 5 is 4. So the answer is 4 square root of 5. And I'm not going to cancel the square root with a non-square root, right? We have to sort of keep in mind that those are separate things. So it doesn't cancel with the square root, it's just the coefficients that are not square roots that we're looking to reduce. So we get square roots out of the bottom and then reduce the coefficients, the numbers that are not under square roots.